In this video, I'm going to talk through a couple of the methods that we use and talk some of the details. We won't get into too much in the weeds of the math, but I do want to kind of go over things with you. So jumping into that, the first is private key encryption. This is most straightforward. Both parties know the same key. And so this might look, well, the drawbacks is that anyone with that key can decrypt. So you don't have any way of knowing if that key accidentally got loose and there's copies floating around. The idea behind this approach is this is actually very similar to the +2 or the ×7 or that kind of math. You basically both know the secret function So if you added 2, your friend will subtract 2 and they can get all those numbers back. This is private key encryption. You both know the secret to encrypting it and decrypting it, and you just undo whatever the person did. You do all the steps in the opposite order. A second idea of encryption is related to hashing. Now, hashing isn't necessarily just for encryption. Hashing is a one-way function that transports an input into a fixed length piece of data. So in other words, an example of this might be multiply by 1028 and keep last 3 digits. So if you multiply something by 1028, no matter what that original number is, and we're assuming these are all whole numbers, you're going to get some number bigger than 1000, right? Because if you multiply 1028 by 1, you're going to get 1028. And then the idea is, regardless of what happens, you only keep these last 3 digits. And so that means every time you do this hash, you always get 3 digits back, but those 3 digits are going to be dependent on what you had before. But since you lose data, you don't know the first digits, you can't work backwards. It's literally impossible to work backwards from the hashed data. And why this is useful is because it can be used to check passwords without storing passwords. So if you send your password to a website and then they store it somewhere, anyone who can look at that data or hacks that website, they can find out your password. But if instead we hash your password, that gives something that's not your password. It can't be worked backwards to get your password. But in the future, anytime you enter your password, they can rehash your password and compare the 2 hashes. And there are ways to hash that basically mean that you can pretty much guarantee that there's no way that someone will falsely guess another password that happens to hash the same as yours. So yes, technically with most hashing, with a hashing that's simple like the one I set up here, a lot of numbers will kind of overlap because you can have, there's only 999 possible last 3 digits. I guess there's 1,000 last 3 digits. And so all of our numbers will hash to one of these. But with proper kind of fancy hashing, you can minimize that or eliminate the possibility of things resulting in the same output, basically by using larger numbers and fancier math. The last bit of encryption we're going to talk about here is RSA encryption, also known as public-private key or asymmetric encryption. And in this case, there are a pair of keys, a public key and a private key. The private key is not shared, the public key is shared. And the public key can be used to encrypt some data, and the private key can be used to decrypt any data locked by that public key. So I talked about this briefly before, but the idea is private keys are always the public keys, not private keys, public keys are always the product of two prime numbers. Then there's a fancy math that can be done by combining this, whatever data you want to do with this public key, that then by knowing this is the two prime factors of the public key. So what's cool about this is the public key is really easy to generate if you know the private key. And the private key is pretty easy to create as well, because you just pick two really, really big prime numbers and multiply them together. But what's really hard is to go from the public key to the private key if you don't know one of those factors. Because the way that computing works, basically to find it, you just have to trial the numbers smaller than it. There's some fanciness we can do to skip stuff, but you basically have to try dividing by every number smaller than the number that you have, that's your public key, and see when it works out. And at the time, currently, these public keys are so large that with current computing, it would take thousands or millions of years to figure them out. To factor them using traditional methods of kind of guess and check. But as we talked about before, basically you do some math with that public key, and that math is really easy to undo with the private key, but it's not possible to undo with the public key because you end up losing some data that you would otherwise. If you're really interested in the specifics of the math behind this, let me know and I'll kind of point you in that direction.